Welcome to this workshop on ASR. I think we have a group of people online also, and some people here in the room as well. Now, let me first tell you what this nature of this session will be, and just then give you some context before our students and research scholars take it over. This is meant more like a place for us to discuss what we are doing from a practitioner's perspective, right? We're not trying to, like when you write a research paper, our goal is to be able to show this is what we did, this was novel, this is new, this is the reason why this paper should get published, right? Here our goal is to tell you, when trying to do ASR for Indian languages, what are the practical challenges we have and how we go about solving them and sharing the tips along the way. And we'll also be doing a hands-on session. So we have about a maybe 90 minute session now, given that we had some delay starting off. We'll do talking for about not more than 30 minutes, and for about an hour we'll do hands-on sessions. So we'll have students who will show you. We will not have the room to allow you to do this yourself live, meaning you're not sitting with a laptop and trying it out, but the intention is that you can look at this video will be up on our website and you can follow along, and more or less it's self-contained from starting from scratch, actually taking these models and training them and improving them and so on, right? Almost to the level of asking the right research questions in this field. So that is really the plan, right? So with that thing out of the way, I'll just tell you a bit about broadly what we have been doing in the ASR space. So as in the morning you might have heard about these three axes, right? Data sets, models and applications, and we have been doing a bunch of things in each of them. On data sets, we have been, as you know, there's not enough labeled data out there. So we have been doing quite a bit of work on mining data, right? So in the case of ASR, data really is a piece of audio and the corresponding text that is being said, right? So this pair is typically not available. So our goal is, can we go and find these pairs from large amounts of data? So one thing that our students have been looking at is, if you take corpus like All India Radio's corpus, right? What do they have? They have lots of stations, audio recordings of different broadcasts, and they also have the PDFs that were used to generate or by the newsreader to read out the news, right? So you have these two things. You have some 1 hour audio and you have some PDFs. Now, can you take these two source materials and identify chunks of 5 to 10 to 15-second audio segments and the corresponding sentences that are being said? So this is what we mean by mining, right? Now, why would we do this? Hopefully the volume of data like with All India Radio is large enough that even if you could get a fraction of that data that is appropriately aligned, we will get pretty large data sets. Yeah, so the idea is, if you can even mine a fraction of that data set, then we create fairly large data sets, which are usually larger than existing data sets by an order of magnitude. So we have done that, and the team will explain to you the process and how that mined data is valuable. Even though there is sometimes some noise in the alignment, the font OCR might not work, the audio might contain something extraneous and so on. Other thing we are doing on data is we are starting an effort to collect data across the country. Unlike other types of problems in AI, in voice or in ASR, we want to capture people's voice signature, right? So we want diversity across the people axis also, apart from, let's say, linguistic or domain diversity and so on. And hence, over the next 1 year, we are starting an effort to collect data from 500 districts across the country, right? So it's a very large effort. So we would like to capture voice signatures of people across the country, and we would like to then release this data in the open source, right? So that's one major thing in data. And the third thing in data is that we need good benchmarks. So if you have been working in this space, you will realize that the benchmarks that we have are not good enough, in the sense that they are noisy, they are small, they are not diverse, they have issues with the lexicon and so on, right? So we need to create benchmarks on which we are able to, with authority, say that this model is better than this by this many points, right? And we've been discussing that in the morning session as well. So on data, mining data at scale, even though slightly noisy, very valuable. Collecting data from across 500 districts, and thirdly, creating high quality benchmarks. In today's session, we'll talk about the first point. How do we mine data? How did we do it? How much it helped, and so on. Kaushal will be talking about that. On the models part, this ASR domain has gone through a bit of a change over the last 10 years, as have other domains. Earlier, you had modular architectures doing speech recognition. Maybe there would be some kind of a feature extractor from audio. Then you would do some kind of a pronunciation model, then you'd have a language model and so on. In between you'll have some HMMs for some acoustic modeling and so on. That has sort of now been unanimously improved upon by end-to-end models, right? So you have models that are end-to-end, which are optimizing just one objective function, which is word error rate, and everything else somehow is implicitly trying to do different things that we were expecting, right? And within this space, there are many different technologies which have emerged. One is, for example, CTC-based models, right? Where you try to, the problem with audio is, ASR is you're giving audio on one side, so frames are with respect to time, right? Whereas the output is with respect to characters. So both are sequences, but they don't have an obvious alignment, right? I could say "k" for a long period or for a short period. So how do you align the sequence of audio frames with sequence of output characters? So to tackle this problem in end-to-end models, there have been various ideas. One idea already in the last decade was the CTC loss, which has been applied to ASR maybe around 2014 or so, and we will show you some results with doing that. The key idea there is that I will include a blank symbol, right? So suppose, let's say, if I am saying B, right, then I might decode B, 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 B 10 times, but I know it's a single B, right? But the problem with this kind of decoding is, how do I know if there are two B's? Or if I want to write the English word B double E, right, then how do I know there are two E's? And the way this is done is you include a blank symbol, right? And in CTC loss, you try to maximize the probability across all possible alignments of the output to the input. So that's one broad thing. I'm just giving you a sense of where the field is going. Then there is this encoder decoder architectures. Somehow it's called in the speech domain listen, attend, spell. Basically, you take all the audio data, create some representation of it, and then decode on the text side, so that you decouple the encoding from the decoding, right? So you can consume all the text first, could be many frames, or all the audio, and then decode only some characters at the output, right? So that also works. But of course, the problem is that you have to first process the entire audio stream before you start decoding, right? So that's ability to stream recognition becomes not possible. And the final method is transducer, where the idea is you have a model to predict both text and audio separately, and then you join them, right? And I'll not go much in detail, because I think what is more interesting is you see what the students have to say. But these broad ideas have come. But we have made a migration from modular architectures to end-to-end architectures, and within end-to-end we have these ideas of CTC, encoder decoder, or LAS, and also these transducers. Transducers seem to have the best features. They are compact, they can do streaming, but they're hard to train, right? So that's where the compromises really are, and we have been playing with all of them, right? So you will hear about models we have been training with CTC. We have not done much work in LAS so far, but we've also been training transducer models internally and so on, right? So that's the models bucket. So other part in models is self-supervised learning. Just like in NLP with start of Elmo and BERT, you had this big revolution of taking unlabeled data and training language models. We have a similar thing happening in ASR, where I can simply take audio, of which there is a lot, right, and train a model to learn basic patterns of what audio sounds like, right? And it is better this way because you can take diverse data across different domains quite easily, and you can do self-supervised learning. And then you fine-tune this self-supervised model with small amounts of labeled data, right? And this is again something that was shown to work with English first, and we have quickly followed up and showed that you can do it with Indian languages. We'll have Tahir speaking about how we train such models and how they are useful. This is actually the wave-to-vec family of models, and we have an Indic wave-to-vec family. The third thing I wanted to say about models was there's an operator choice, right? Interestingly, in ASR, you're trying to somehow have short-range features, but also long-range features, right? If I'm saying, let's say if I'm saying Ram, then the word Ra is followed by the sound So I need local features there. Ra is maybe it's happening over, let's say, 1 second, right? So maybe I'll have 40 frames of 25 milliseconds. So I need local context, but sometimes you also need distant context to be able to correct some issues with the language modeling side. So how do we combine these local features reliably with distant features or distant relationships between audio frames has been one recurring theme in how the research community is thinking. And there you have various things, right? So you have convolution as an operator which comes from the image domain and does a very good job of locality. So local information is well preserved reliably. But then you have things like transformers, which are again coming from NLP, but they do an excellent job of distant relationships, right? And what you will hear today, also I think Kaushal may talk about it, which is conformers, which combine somehow the ability to have reliable local information, but also have some transformer layers to have much distant information, right? So how do you combine these two are also there. So if you look at it in a big perspective, models, people are doing self-supervised learning. They are talking of end-to-end models which have some choices, and there are some operator choices, and we will discuss about some of them. Finally, data is gone, models is gone. Finally, on apps, we have been doing a few things. One is efficient models that can run on phone. So we would have Gokul talk about how we took a model and actually make it run on Android, right? So there are basically some practical things to know there. How do you take a PyTorch model, which is very dynamic, make it static, make it maybe quantized, run on the phone, what works better in Android, and so on. There are a few different interpreters that are available on mobile, so what is a good choice there, and so on. He'll talk a bit about that. But as you've been hearing in the morning, there's quite a bit of interest to have these models run on phones, especially voice, because it's somehow your personal information. The second thing is domain-specific efforts. We will not talk much about this, but it's very clear from the discussions that we have had with different people who came today that it's important to build models for, let's say, e-commerce or models for payments, right? And the ability to fine-tune or distill a model for a particular use case improves the trade-off of accuracy and model size, right? And so we will engage in a bit of this in the year to come. And finally, you might have seen the video of Chitralekha, which is also an application. Our goal there is to provide same language subtitling plus followed by translation. NPTEL is using our tool. Potentially Planet Read will also use our tool. So we are hoping that by being able to provide people tools for transcription, we not only improve their productivity, but also then collect data which can further improve these models, right? So with that, I'd like to leave you. So I think I think if people are following this space of ASR in the next 1 year or so, at AI for Bharat, we'll make some meaningful progress on data. We'll collect data from across the country. We will create benchmarks which are hopefully more reliable in earmarking performance of models. That is one key thing. And two, we will continue to evolve the training of models, right, and push the state of the art there, and push for efficient and domain specific models, right? So with that brief overview, I would pause here. We can maybe take a question or two if there is anything in the room or in Zoom. Else we can move to the next segment. So any questions? Yes, Zoom is clear. To the data will have commercial friendly license. The data that we collect from across the country, that is our India 500 mission, that will be open source, right? So it will be open source and also available with the license to use for commercial purposes, right? So that will be hopefully of use to commercial partners also. How relevant is Kaldi in the current times? Yeah, so as I said, right, there is this movement away from modular engines to end-to-end engines, where a single end-to-end system can then go and I think somebody was talking about it, Professor Pushpak was talking about it, that there is a need to combine things like rule-based engines and deep learning-based engines. And rule-based engines make sense when you have lesser amount of data. We believe that in most Indian languages, over the next year or so, we will have enough data to both by mining and by actually collecting high-quality data to push for neural models for them, right? End-to-end neural models, right? And but it is not clear that the amount of data that we have, the neural models are the state of the art. So they need to be rigorously shown that with the same amount of data, you train a model with Kaldi with specific features and so on. You do a neural model, you compare them, and then you show that the neural models are actually accurate. We are working with the hypothesis that that is the case, but we are happy to be proven wrong for the sake of more accurate models to be there. So my sense in response to that would be that neural models may continue to do better You had a question. A good question. There are two parts there. There's a process part and there is this the technology part, right? So process-wise, what we are going to do is we are going to at IIT Madras put out a tender for people to come and work and collect data on the ground. And this is massive, right, across 500 different districts. But that is that's not the interesting part of the answer. The interesting part is we'll use this Karya app, an app that has been designed at Microsoft Research and now is spun out as a separate company. This is an open source tool. It's a phone app where you can simply register and start collecting data. You'll get prompts and then you can record it. And the advantage of this is it works without internet connectivity also. So you can go somewhere, record it in the field, come back to your location and then upload it, right? So we are thinking of setting up camps in different districts where maybe for 1-2 days and then get local folks to come, pay them and collect data, right? It's also important to discuss types of data. There is one kind of data which is read speech. I'm told to say this, I say it. And then there is extempore speech, right? I am just speaking like I'm doing now, right? Where I'll be stuttering, I'll be stammering and so on. And then there is speech which is conversational speech. Two people are talking with turn taking and so on. And finally, there is voice commands. I'm just assuming I'm talking to a computer, saying something very specific and transactional. We are trying to collect all these segments, okay? And we are coming up with guidelines on how to collect it. In fact, we release a quarterly report called Data Report in AI, where sometimes we put out these ideas and we ask for feedback, right? And we have a certain mix, I forget the numbers, but certain mix, something like half the data will be read speech, the other half is split between the other three categories.
So when you are not pronouncing in Tamil, we have this 3 type of which is unique thing, and na which is a unique thing, and I'm pretty sure that in every other language we have it. So when the pronunciation is not correct, probably it is coming out what the person was speaking. So in that aspect as well, the data is not accurate. So I'm just sharing my thoughts.
Sure.
Just seeing that it's like my language, so that it is getting better in terms of technology. So I would request when you are unless otherwise the person who knows that particular language well and good, and the evaluation is being done, models and everything kind of becomes you will not attain your final purpose with all that work going not doing.
Absolutely. No, thanks for the feedback. Yeah, very good point. See, I think what you raised, I think 2 points you raised, right? One is the source prompt, or the prompt source. It should be native, right? If you take sentences like, "Hey, I had a cool party," and you ask people to record that in some rural place, it doesn't make sense to them. So we are doing that. So one of our tasks over the next couple of months is to create these prompts that are source native, right? We are taking them from local Wikipedia pages, sometimes taking Indian content and translating them ourselves. Both we are doing because we have also sensitivities around copyright. It's not easy to get source native data in many languages which is copyright free. So, but the key thing is we won't take something that looks like, hey, I'm going to party. So that we are trying to have a process around that now. Probably we didn't do that very strictly earlier, and that was one thing. The second thing about pronunciation, so firstly, we are doing it in a closed room, as opposed to taking some mobile to somebody's house and recording it or letting them set the context. We are going to set up something like I wouldn't call it studio quality, but some room with some isolation, there's no background noise and so on. And secondly, we will be training coordinators to give instructions on how to record data, right? So it's not a crowdsourcing model. It's almost like get people in, do a mini training and then start recording. Now about pronunciation, there we may differ a bit, right? So my sense is that in voice, we want to capture people's signature, right? How they are pronouncing it. There are 3 kinds of lurs in Tamil, right? That is true. But the way those 3 types of lurs are said by different people, that also varies, right? and there of course we don't want the wrong lur to be said. That we don't want.
Slangs can be different, which has to be implemented and incorporated, but the way it is being pronounced, it will give totally different meaning. So that's what I want to kind of emphasize.
Okay, got it. No, makes sense. I think we'll do some quality control around that. I think mistakes do happen and we need to correct that. But in this broad effort, we have done some smaller efforts so far. In the broad national effort that we do, we'll spend a lot more time on process, right? And we're putting that out in open source. So you should write to us and just share your feedback also more formally, and we'll incorporate that.
So are you considering a noisy speech as well, or only pure speech while collecting all these data?
So that is a good question. Our sense is that you should collect high quality data because the ability to later deteriorate quality is possible, right? How realistic is that noise, one has to see, but we are looking at some things and it seems possible to add noise later. So our concern, in fact, this was a major concern. If you ask people to collect data in 500 districts, and if you take it to their homes, it's not a background noise. The way India lives is quite noisy, right? And we decided not to do that. We'll not record at homes. We'll get them to a semi-studio like setup and record it, and then later think of ways to deteriorate data, right, if required. However, there will be other kinds of noise, as in, of course, not the acoustic noise, but there will be noise, for example, if you do extempore. There's noise in the way that is recorded. Or if you do conversational speech, it's possible that two people speak on top of each other. That kind of non-ideality we will still capture, right? But not necessarily acoustic noise.
So you mean the environmental noise also?
That will not be there.